convection currents from cooling it down or warming it up, depending on what you're trying to do. Because this works both to keep things cold and to keep things hot, because it's limiting heat transfer from the outside or from the inside. All right, so everybody good with convection? How we handle convection? How do we handle radiation? All right, and it's really just that light is radiation. And by the way, radiation is not a nasty word in science. It does not mean deathly. It just means electromagnetic radiation. There's two kinds of radiation physics, the electromagnetic type and the nuclear decay type. That's what people usually mean when they say radiation. But light is also radiation. So we all know from everyday life, light hits a mirror and reflects. So any electromagnetic energy that hits a mirror reflects. And that's exactly what the mirror on the inside is. So typically, they will put the mirror, they'll make the inner jar out of glass because they want it to be a bad conductor. And then they'll paint the mirror on the outside of the glass. Why not on the inside? Because you don't want, there's a chance that you put tomato soup or something that it'll eat up whatever metal you put on the inside. So you put it on the outside so it doesn't interact with whatever food you're putting in. And glass is very neutral on that. So put it on the outside, and then it radiates that, reflects right back in, and we don't lose much temperature. Yes?
Can you explain down
The whole glass one?
yeah, like the last one.
Right, so what happens is I've got a glass jar and I paint the outside with a kind of silver shiny paint. Any hot thing that I put in, that heat energy wants to radiate out, but it hits that mirror and just comes right back in. So I don't lose it.
On the inside.
So anything that I put in that's hot or cold, if I put in something hot, the heat tries to leave, but it hits the mirror and reflects back in, so it can't leave. If I'm putting something cold, thermal energy from the outside tries to go in and it hits the mirror and reflects back out. So I don't get any transfer past the mirror. That's a bit of a lie, because unless you're spending a lot of money on a really good mirror, it's not ever perfect. All right, but really, really good doers, they call it in science, they can keep temperatures constant for several days. All right, so like my brother's a vet, he does a lot of artificial insemination, so what they have to do is they have to keep all the bull semen in a big tank of liquid nitrogen. And he says that sometimes they can go a full month without having to put more liquid nitrogen in there if you've got a good enough furnace. All right, so I mean, it's expensive, but it's worth it in a case like that. All right, so are we good on this problem? Anybody got any question then about any of the other stuff on the test other than my H section, which I'm going to let the other people go and we're going to talk H stuff. So.
Number one for finding work, isn't it?
It is P delta V? Yes, except for if you got a straight line. So you're not H, right? All right, so what happens is then for you, we had this situation, right? The other way to find work is simply find the area of the curve. And I told you the way to do that is find the area of the triangle, which is 1/2 base times height, and the area of the rectangle and add them together.
Okay.
Right? Does that work?
Yeah.
Okay. Anybody else? Any other questions? By the way, guys, I will be here early Monday, and I'm gone on Thursday and Friday, but I'll be home on Sunday and Saturday. And I'm not going to live on my computer, but I will check it from time to time, so if you have questions, I'll try to get back to you. And I did finally get linked so I can look at the homework stuff from the assignments as well from home. Yay, I think. Yes?
When are these videos coming up?
They're up. Did you all not get my email?
Today's.
Oh, that I don't know. I think the guy who does it for us is already on break. Sorry.
So we have to go
Tell me which one 13 is. I mean, what's the question?
I don't know, I'm just asking, like, overall, probably not going to go over it, you know, questions, maybe do a
I'll be honest, I got so tied up reviewing for the test that I...
Usually we, you know.
No, we usually do. So, yeah, let me do that. The only trick on that homework, there's two little things that you have to pay attention to. One is that they define their Q, is it the Q or the W? One of them they define opposite from me. So I do W by the gas, and they define W on the gas, which just means they're going to be a minus sign different. as you go. Then the other thing is, when you do that problem, there's a kind of trick that saves you a lot of time. So first off, kilo means 1,000, so don't forget that. And then we have this going on. So I have 1 cubic meter and 4 cubic meters. And what we're looking for is the W, delta U, and the Q. Basically, that's what goes on in the problem. So to find the W is pretty easy, right? You just take the delta V, which is 3, and you take whatever the pressure is. In this case, it's 120,000, right? And so you just multiply that together to get your work. There's zeros on both of these, and this one's positive because they have it going like so, right? This one's positive, this one's negative, right? Then, when they ask you to find delta U, the easiest way to do that is to remember that it's 3/2 PV. For the top and bottom. For the sides, you can't do that, but for the top and bottom, you can do that, right? So basically, it's just, you can take 3/2 times whatever number you got for the work up there, right? So you can do it that way. Then for the sides here, you'll have to do the, there's no work done, right? So you can, you'd have to go back and do it from the temperature point of view. So you say 3/2 NR delta T. Then the other thing that's kind of tricky, if you want to consider it's tricky, is that you can't round any of the numbers until you're done. They penalize you if you round too soon. So keep all the numbers in their full glory all the way through and write them down, because after you've entered all 4 numbers, it doesn't show you all 4 very easily, so write them down so you have easy access to get to them. But if you get stuck and can't work your way through, nothing on this particularly directly pertains to the test, and it's not due until after the test, not due until the 9th. So I'd rather have you make sure you get a good grade on the test, and after the test, or on anytime Monday, you can come and I can still help you get the right answers on this. Does that make sense? And I think you'll find that just the 3 problems, 2 of them are not very bad at all. The first one is the kind of long one, but even there, if you're careful and you go through the definitions we have, it should be pretty straightforward. So you understand you can easily find the temperature at each corner simply because I know both P and V, and PV equals nRT. So, and they tell you how many moles, and you know R, so it's really easy to find the temperatures in the corners. And other than that, I think the main problem people had is it's really picky on accepting your answers, and if you round too soon, it'll mark you off. All right. Anybody else on anything else before I launch into the stuff for the H section? All right, so if you want to hang around, fine. If we get it done early, and guys, I'm going to stay until the last one of you leave. So if you have questions of any sort that you want to ask me after class, I'm staying. Although I know some of you have real lives that you have to go do something else, but I'm going to hang around. So H guys, let's take a look at what you need to do on this problem. So I'm assuming that the only questions that we have for you guys is finding the work done on the isotope. Are we good with that? Right, because as far as these are exactly the same answers and approaches that I did for the rest of the class. So the H section, the only thing I need to worry about is the isotope. Is that right? All right. So the way this is done is, well, let me make that a little more obvious. The thing that makes this slightly tricky is that I know that the work is P delta V, but P is changing and V is changing, and so I can't use the methods that I use for the straight lines. So instead, what we recognize is if PV equals nRT, and I want P dV to find for each tiny little step, that's basically saying it equals nRT dV. Excuse me, not at all true. What's P? P is equal to nRT over V dV. So what I did is, here I just divided both sides by V to say that P is equal to nRT over V. Does that make sense, everybody? I basically just said solve for P in terms of V, and then I put that number in for this. And now what I notice, on an isotherm, N's a constant, R's a constant, and T is a constant. So when I integrate P dV, I'm saying it's nRT dV over V. Do you see how that step happened? My work, each tiny increment of work is P dV, but P is equal to nRT over V, and I put it here, but nRT is a constant. You can always pull the constant out of an integral. Please let me know if this isn't clicking. All right, what are my limits of integration? I'm going from here to here. I'm calling them V1 and V2. It was 2 cubic meters and 8 cubic meters. So I go from 2 to 8. All right? Now, this is the only tricky step, and you either know it or you don't, because there is no way at this level of calculus that any of you have had to know how to derive that. You had to just learn it. And what does this integral come out to be? It's the natural log of the ratio of the limits. They don't teach you to do it this way in math class, and I've challenged them and they acknowledge that I'm right, but they just don't change their ways. The problem is you can't do this. You can't say it's nRT ln V between 2 and 8, and then say nRT ln 8 minus ln 2. Does anybody understand why? It's undefined. You can't take the log of 8 cubic meters. You cannot have units in the argument of a logarithm. So even though that's how they teach you to do it in calculus, you can't. So you immediately use the law of logarithms. This is if you subtract logs, that's the same as dividing. So when you go here and you divide, the units cancel and we're home free. But this intermediate step is an impossible step. And I've asked all kinds of people, what's, even from a theoretical point of view, I mean, maybe it's lazy, but how even theoretically can you go here and nobody can answer me? So I now teach in the physics class, whenever you have an integral like this, the answer is the natural log of the ratio of limits. And I don't teach to take the step. It's always going to be the natural log of the ratio of the limits. So in this case, it takes me here directly. The units cancel, and that just says it's nRT, natural log of 4. And your calculator will know that number. And the T that I use is the T that you found from evaluating the temperatures earlier in the problem.
Delta T?
No, it's not a delta T. It's the, see, this is an isotherm,
Oh.
so there's only one temperature associated with it. So this step is only for the isotherm, not for any of the others. Is everybody good with that? Yes.
How did you get that second step?
This one here?
No.
This, what I said is, I know that this is what I'm looking for, is P dV, but P is equal to nRT over V, so I just substitute P in terms of V. P equals nRT over V, nRT over V, that's the P part, the dV just stays. Okay, let me back up. PV equals nRT, no problem, right? Solve for T, divide both sides by V. This should be true. And if I've got P dV, instead of P, I write nRT over V.
Oh.
Okay? And then since nRT is a constant, it comes out, the dV over V stays there. Does that work? Are we good? Or if not good?
I can't find the temperature, we use PV equal nRT.
Absolutely. And I tell you it's 1 mole, I believe.
And then we plug that T into our nRT.
Right. So the N is 1, the R, I mean, or however many moles I give you, the N is the number of moles. R is, of course, just the constant. And T is the T that you find out using the ideal gas law from the information I give you on the graph.
that is our whole cycle for 1 through 4.
Yeah, so you, no, that's only going from 1 to 3. You still have to do this part. For those, this part and this part are exactly the same as what I did in class for the other people. Because their graph looked like this. So the only line that's different is this. So you now just got this information. This and this are the same numbers I gave you last time.
Oh, yeah.
Because they're the same numbers for both classes. And I posted the answers for that on the board, so you can double check and see if you got it, all right? But so you're gonna have to look at the non-H section to get some of the numbers because I just stole them from the work on the first question. All right, so guys, any other questions at all? Any parts of this at all? Any of the stuff that I threw at you today that should not be too new if you've been doing the homework. Okay, and like, again, what I'll do is I'll try to check my emails on Saturday and Sunday to get back to you. And that failing, I will be here early on Monday with nothing to do but answer questions. All right? And if you can't find me in my office, check down in 109. Because sometimes I drift down to the room down there to answer questions. Okay, I'm staying around. If there's other questions on homework or any other part of the test, you'd rather just talk to me one-on-one. I'm going to stick around until the last people leave. I'm planning on it, because I'm not even having to cook this year.